Okay, today we are going to learn how to multiply and divide integers using integer chips, also called counters. Okay, you are going to need your modeling notes to go with this video. As we go through the different models, you need to make sure you're recording or writing down everything in your chart so that you will have good notes to help you with your homework. If you don't have the modeling notes worksheet, then go ahead and make your own table and do this on notebook paper. Okay, let's start with multiplication. Our first problem is 4 times 3. Yes, we all know 4 times 3 equals 12, but the purpose is to be able to model this problem using the integer chips. So first we need to think about what does it really mean. Well, you probably will recall back in elementary school when you did multiplication, you learned that multiplication was repeated addition and that you had groups of numbers. And that's what this is. Our first number refers to the number of groups. So number of groups is what the 4 is. We need 4 groups. And the size of the groups is going to be 3. And each group we want 3 positives. So what exactly does it mean? We're going to fill this into. It means 4 groups of 3 positives. Now, remember to model using the integer chips or the counters, if you actually have them, the red means negative, the yellow means positive, or you could draw your own integer chips, your own circles, put a positive sign and a negative sign to represent positive and negative, or you could just use the symbols themselves, which is what I'm going to do. So I need 4 groups. That's the first thing I'm going to do. I'm going to draw 4 groups. 1 group, 2 group, 3 groups, 4 groups. And each group needs 3 positives. So I will go and I will put 3 positives in each group. Pause the video if I'm going too fast. Okay, once you have your model, look at it. Everything is positive, so just go and count them all. And there's 4, 5, 6, 7, 8, 9, 10, 11, I'm sorry, 3, 6, 9, 12. I wasn't counting right, was I? There are 12 positives, so that's your answer. So 4 times 3 equals 12. And you already knew that. Let's look at our second example. 4 times negative 3. Okay, so let's write down what this means. This means we need 4 groups because that first number represents the number of groups. So we want 4 groups of, the second number represents how much goes into each group. We want 3, but this time it's going to be negatives. 4 groups of 3 negatives. So let's draw our model. I'm going to draw 4 groups, and each group gets 3 negatives. And then you just count up all of your negatives, 3, 6, 9, 12. There are 12 negatives. So 4 times negative 3 equals negative 12. What about this problem? Well, we know this is the number of groups, the negative 4, but can you have a negative group? No, you cannot have a negative group. So there are actually 2 different ways that you could model this problem. The first way is to take a look at the negative and what does the negative really mean. We know the negative really means the opposite. So we're going to rewrite our expression and we're going to take the negative and put it on the outside because it's going to be the opposite. And then inside parentheses, 4 times 3. So what exactly is this saying? This is saying we want the opposite of 4 groups of 3. 4 groups of 3 positives. Gotta squeeze that in there. And to model it, we still need 4 groups. 1, 2, 3, 4 groups, but we're going to put them inside parentheses. And on the outside of the parentheses, I kind of ran on a room, you're going to put the negative symbol. This shows the opposite of. And inside each group, we want 3 positives. All right, so now you're ready to go count them all up. You have 12 positives. But remember, we have these parentheses. We want the opposite of that. The opposite of 12 positives is 12 negatives. So negative 4 times 3 equals a negative 12. Okay, so I told you that was one way of modeling it. The other way of modeling it is using something that we call the commutative property. Go ahead and write this down. In math, you have certain properties that are kind of like rules. It's something that will always happen no matter what. And the commutative property only works for addition or multiplication. It does not work for subtraction, it does not work for division. But what it says is that you can change the order. What this means is that you can change the order of the factors and you will still get the same product. You will still get the same answer. So if I were to go back and look at my 4 times 3, we know that 4 times 3 equals 12. If I were to change the order of my products and write it as 3 times 4, would it still equal 12? Yes, it would. If I had 5 times 3, that equals 15. If I change the order and rewrite it as 3 times 5, will that still equal 15? Yes, it will. So we can change the order of our factors, the negative 4 times 3, and rewrite it as 3 times negative 4. And now we would have 3 groups of negative 4. So let's model that. 1 group, 2 group, 3 groups. And in each group, there's going to be 4 negatives. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If you count them up, 4, 8, 12, you still get negative 12. You still get the same answer. The commutative property is something that you're going to use a lot, especially in algebra units. And when we get to the algebra unit, we're going to work more with that. Okay, let's look at our last example. Negative 4 times negative 3. So this means negative 4 groups of negative 3. But again, we can't have negative groups. So could we rewrite this? Use the commutative property and rewrite this as negative 3 times negative 4? No, because you're still going to have negative groups, and you can't have that. So instead, we're going to do what we did here, and we're going to take out this opposite, this negative sign, and we're going to rewrite our expression, take out the opposite, and it's going to be 4 groups times negative 3 inside the parentheses. So now we're saying that we want the opposite of 4 groups of 3 negatives. And now we're ready to go ahead and model it. So we need 4 groups, but we want the opposite, so we're going to need parentheses. Put that negative sign on the outside of the parentheses. Okay, now we can draw our 4 groups. Close the parentheses. Each group is going to have 3 negatives. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then if you count up all of your negatives, you get 12 negatives, but we need the opposite of that, which makes it a positive 12. So negative 4 times negative 3 equals a positive 12. Okay, let's talk about division. We're going to talk about division now. So division is basically the opposite of multiplication. So instead of having the number of groups and the size of groups and trying to find the total or the product, we're going to be given the total amount. And we're going to be given the number of groups, and we want to find the size of groups. How many integers, or how many integer chips, or how many counters go into each group. So our first problem is 12 divided by 3. The 12 represents the total chips that you have. Total chips, or total counters. We have 12 total. The 3 is going to represent the number of groups. So we want to take these 12 chips and we want to put them in 3 groups, all that are equal sized. So what exactly does it mean? It means 12 equally shared, or split, or divided into 3 groups. And let's model it. Okay, we know we need 3 groups. So here's 1 group, 2 groups, 3 groups. I don't know yet how many goes into each group, but I know the total is 12, that I need to share the 12 equally. And it's positive 12 that we're sharing equally. So I'm going to go 1, 2, 3. I'm just going to continue sharing them equally into each group. 4, 5, 6, 7, 8, 9, 10, 11, and 12. So now I have shared my 12 positive chips equally into 3 groups. So each group gets how many chips? Each group gets 4 positive chips. So that is your answer. 12 divided by 3 equals 4. Again, remember to pause the video when needed so that you can stay caught up in the notes. If I'm going too fast, pause it, you can rewind it. That's the magic of video. Okay, let's look at our second example, negative 12 divided by 3. So this is saying that we have 12 negative chips. So 12 negatives equally shared, or split, or divided into 3 groups. So the model is going to look, we're going to do the same thing we did on 12 divided by 3. We're still going to have the 3 groups, but this time instead of sharing 12 positives, we're sharing 12 negatives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And you can see that each group will have 4 negatives. So negative 12 divided by 3 equals a negative 4. It's pretty easy, right? Well, let's see if we can make it a little bit more tricky. Next problem, 12 divided by negative 3. Okay, again, 12 is the total number of chips that we have, and this negative 3 is the number of groups. But we cannot have, please write it, cannot have negative groups. Well, we ran into this when we were doing our multiplication with the chips. So can we just go ahead and use the commutative property and change it and do negative 3 divided by 12? Would we get the same answer? Is that the same as 12 divided by negative 3? No, it's not. Okay, this one would actually be 1/4, so 25 hundredths. Okay, so you can't do that. Commutative property does not work for division, and it does not work for subtraction. So the only thing that we can do is we can take out this negative and put it on the outside of the parentheses. We'll rewrite our expression. We're going to want the opposite of 12 divided by 3. So what does it mean? It means the opposite of 12 shared, split, divided equally into 3 groups. So we're going to need our parentheses again on the outside. Put your negative symbol to represent the opposite. And we still want 3 groups. So 1, 2, 3. I'm going to close my parentheses. And we're sharing the 12. So 12 positive. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So what is the size of each group? Each group has 4 positives. However, we want the opposite of that. And the opposite of 4 positives will be 4 negatives. So 12 divided by -3 equals a -4. And our last example, -12 divided by -3. So this time we're sharing 12 negative chips, or 12 negative counters, into -3 groups, which, can't have that negative groups, can we? So let's pull out that negative, rewrite our expression, and it's going to be 12 divided by 3. Now be careful, you're not pulling the negative from the 12, because this is the total chips that we have, 12 negative chips, and we can have negative chips. Okay, we're pulling out the 3, or the negative, from the number of groups from the 3. So what does it mean? It means the opposite of (12 negatives shared equally into 3 groups. Okay, let's do the parentheses, put our negative sign on the outside. We still need 3 groups, 1 group, 2 groups, 3 groups, close our parentheses. And what we're sharing are 12 negatives. So I'm going to share 12 negatives in between the 3 groups, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And you'll see that the size of each group is 4 negatives. But we need the opposite, because we have the opposite sign here. The opposite of 4 negatives is going to be 4 positives. So -12 divided by -3 equals 4, or 4 positive.